So we're going to talk to you today about the Connected Officer, bringing IoT to policing. The IoT stands for the Internet of Things. Just a quick question, or a quick question to find out how technical you guys are, what groups you work for. Who here is in government? Okay, about half of you. All right, and how many are super technical, 400 level, 300?
Okay, no questions then.
200.
From you people.
Yeah. Okay. Who just wants to learn about IoT? No?
And law enforcement. There you go.
Yeah, okay. All right, so we're going to talk today, we're going to talk a little about the scenarios that IoT applies to across government specifically. Brandon and I work in state and local government for Microsoft. So I'm a solution architect. I used to be technical. I do more sales, business development stuff now. So Brandon's actually going to handle more of the technical aspects of our presentation today. But I'm going to talk about the use cases. So I work primarily with justice and public safety customers in the law enforcement space for the most part. And we deal with a lot of scenarios dealing with data, connected devices, camera systems, things like that. So we're going to talk about some of the technology layers that are supporting that inside of Azure. Now, I've been asked to put in these slides to talk a little about Azure Government. I apologize in advance. They're not that boring. At least I'll try not to make them that boring. So how many people knew that we had a completely separate cloud from our commercial Azure cloud? Most of you. Okay. How many people just don't want to put up their hands because it's the end of the day? You don't have to put up your hands for that. All right. So Microsoft has developed its own separate government cloud. And what this means is the Amazons of the world and the Googles of the world have gone out and basically taken a part of their commercial cloud offering and carved out a section of it, taken 100 servers and said, okay, this is going to be our government cloud. Right, what Microsoft has done is we've taken several $billion and actually built out multiple instances of Azure data centers across the United States. Now, I won't go through each one of these, but the idea behind it is that we provide a completely physical and network isolated instance of your data, right, and where you're storing your data, which helps us with things like compliance, right? The people that work in our data centers are all FBI background checked, fully screened, make sure they're not bad people and are going to do bad things with our data and compute. So we align with a lot of regulatory compliance guidelines, and I'll go through a couple of those in just a second. So right now, we've got a couple of different regions with data centers stood up. One here, or close to here, in Fairfax, and the other one is in Iowa?
Iowa.
Des Moines, right?
Iowa.
Iowa, I'm sorry. So we've got one in Iowa, and this is basically allows for disaster recoverability. There's more than 500 miles between them. We've got isolated network cable that connects these two data centers. They're very, very secure. Big hairy dogs walking around the perimeter, making sure people stay out, as well as people in there doing that type of thing as well. So we also have two regions that are dedicated for the federal space in the Department of Defense. So these are actually two separate instances that have been stood up specifically for the purpose of supporting the DoD. Pretty fancy, right? And we're actually in the process of adding two new regions. This is 6 times more than Amazon Web Services has. You can see we're not fans of AWS around here, especially not our marketing folks who built these slides. All right, so the Azure compliance, we cover over 50 different regulatory bodies here, I guess. So we've got, I'm not going to go through each one of these. The most important one when we're talking about law enforcement is something called the Criminal Justice Information Systems alignment. And what that means is that the FBI has a very strict set of rules around how data is managed across law enforcement communities. They've written something called the CJIS guidelines, which is basically, 200 pages of light reading around what you should be doing to manage your data in any kind of a data center for law enforcement. And so we do things inside of our data center that make sure that any agency that's using Azure for their law enforcement needs aligns with those guidelines and remains CJIS compliant. And that's really the whole sort of driving force around having those data centers separate, being able to go in and do things specific to the security requirements of those CJIS capabilities, that support those CJIS capabilities. Once again, 38 Azure regions across the world. So we're standing up data centers all over the place. Places where they've got data sovereignty issues like Germany, right? That say, we can't send data outside of the country we're building data centers in those places to support those customers. So, relatively large investment. Luckily, Microsoft has deep pockets, and we can do this type of thing, right? So 38 Azure regions, and I'd like to point out that it's 2 times more than AWS. All right, so this is exciting. So CGIS is covering more than 2/3 of the population. This really means a lot if you're in law enforcement. The very first question I usually get out of the crowd or the audience if I'm presenting to a group of law enforcement people is, relates to CGIS and policy around that. They're very, very, what's the word, careful about where they store their data and who they give access to their data. So CGIS is extremely important, and we actually have to work with the state CGIS security officer at a per state level getting these compliance accreditations in place. So we signed the FBI CGIS security addendum with the FBI across 26 states. We have a whole team of 50 people working on this. So this is a big deal for us as we move across the entire country to get certified across all of those. Oh, and it's 4 more times than AWS has. So. And same with FedRAMP. So on the federal side, so we've got a lot going on. FedRAMP Moderate was approved in 2015. We've got a FISMA High now. Some other things that I don't fully know a lot about because I work in state and local government, but we're doing great things. And it's 2 times more than AWS in this case. Okay, that's the last I'll mention of AWS. All right, so we have over 75 new releases in Azure Government. One of the challenges that we've had is that our Azure commercial data centers were built long before Azure government data centers. And so what happens is every time new services are added to our commercial data centers, we're a few months behind. And a lot of that's to do with some of those compliance capabilities that we have, where every single service that we launch in commercial Azure has to be approved for government as well. So it has to go through all of the audits and the checks to make sure that we don't go out of compliance in that environment. We're seeing new releases, 75 new releases in the last 3 months. And basically what it means is that we're shipping about, every 32 hours we're shipping a brand new cloud service or innovation for government. So it's just pretty exciting, where we're going with it. Okay, that's the marketing piece that's over. So I'm going to talk to you a little about IoT now. Everybody in the room know what IoT is? The Internet of Things? Okay, so I have this slide up here. So anybody have one of these in their house? They're pretty cool, right? I've got some version of this, but this is an IoT connected device. This is a piece of hardware that is generating data and is generating that data in a way that we can, number one, instantly respond to it through, we've got a mobile device that connects to this data path that is sending us real-time information about the temperature in our home, right? It's also giving us historic data, too. So you think we've got hot data, so a hot path data coming in, giving us real-time information. We've also got a secondary data path, and we call that the cool path data, right? And the cool path data is when I can go in and actually look at how efficient my furnace is and how bad my house, or how poorly my house is insulated, right? So we can say, okay, well, our furnace is running all the time. We look at the longer term data stream and derive insight from it, and then are able to take action based on that insight. So that's really what the Internet of Things is all about. It's all about those connected devices and then the 2 different data paths that I mentioned, where we get instantaneous data and we also get archival data that we can run analysis on. And so this is really all about things, and obviously have to be connected to the Internet. I just installed one of those Ring doorbells at my house a few days ago. Anybody have one of those? Same type of thing, right? Someone comes to my front door. I can actually, see who's on my front porch through the Internet connected device. I'm capturing the data. I'm storing it for later use. If somebody comes up and isn't so kind or does something that they shouldn't be doing, I can go back and look at that. And then we can apply analytics to that. So that's really what the Internet of Things is. And it's, Gartner is saying that there will be, by 2020, 25 billion different connected devices. And this is actually pretty important when we start thinking about some of the applications in government, right? So we get into smart cities and education. The ability now for us to be remote is becoming more and more present. I work from home. Brandon works from home when we're not traveling. Having some of those connected devices allows us to do that. I'm sure you all have similar scenarios in your life. Public safety, which we're going to talk about today, is one that's particularly relevant as we move into the new world order of policing and law enforcement, things like that. So they're saying that this is a Cisco quote, but they're saying it's going to be over 4.6 trillion savings in $1 trillion in savings in operational costs for public sector. So I don't know if that means that jobs are going away or if they're just going to be, become more efficient in how they do their jobs, but it's a fairly significant amount of money, right? So let's talk a little bit about the use cases for the scenarios that support the use cases for law enforcement. So I talked to a lot of different groups of first responders and public safety officials, and I think IoT is extremely important in their world, right? And when we think about it, right, where we're having things that are happening, and everything from Boston to what's going on globally, right? The Paris attacks, some of those things that have happened. And the reality is that for law enforcement, the way they look at the world is that a single person has basically the impact to affect many is growing exponentially. And really where we're getting these lone wolves that are popping up, they're doing these random things that law enforcement cannot anticipate. And they need help. They need assistance from people that are on the ground, the private citizens. They need other officers to be there to be able to spot when some of these anomalies occur, right? So we've got something happening, we've got a camera pointed at it. How do we identify that something is not quite right? There's a package left on a corner, there's something going on, right? So they need some assistance to do that. And that's really where we get into some of these use cases for IoT. So the way that IoT works for law enforcement is all of these devices act as force multipliers, where we have one officer on the ground that can be connected to all of these sensor devices around him, and it helps him do his job more effectively, or helps somebody who's dispatching him to do his, or help them provide information so that he can do his or her job more effectively. And here's some examples of IoT connected devices for law enforcement. So we've got a license plate reader up in the top left-hand corner here. These types of solutions, identify vehicles as they drive down the street. They compare them to cloud databases. They throw flags up in real time when something is identified that a vehicle that is wanted. You guys see that thing on TV last year, horrible thing where that reporter was shot on live TV, and then the guy took off in his car. I think it was up near here somewhere, right? And he was driving. How they caught him? He was driving a rental car, and how they caught him was through an LPR system. The LPR got flagged on a light pole somewhere along the highway he was driving and notified the police, and then the police came in and were able to identify him and catch him. It ended badly, as I recall. But so that's the kind of situation and scenario we're going to support. And I'm going to show you a video of New York City and some of the things that they're doing with LPR systems near the end of our presentation today. The other one is drones, where if we can't get to the middle of an event where there's a bunch of people crowded around and something's going on, we can send a drone up now and get aerial footage that streams live back to our police cruisers, to our phones, the different things, the different devices that these guys are carrying. We also have a system called ShotSpotter. Anybody familiar with that? Have heard of it? Yeah. It's really neat. So think about this, right? We go into a city and we set up a set of microphones all the way throughout that city, and anytime a weapon is fired within proximity of those microphones, we can triangulate the exact location of that gunshot, and we can identify the caliber of the weapon, the time of day it was fired, where it was fired, right? And then think about this, right? Let's say that we've got cameras throughout that city as well. If we can link that information together, we can then run the video, hopefully HD video, of the individual or that location and see what was happening, right? And pull plate numbers, pull all of that other information that could help us, right? And of course, we're all familiar with this scenario. I'm sure many of you have it in your homes already as well, where we've got surveillance cameras that are connected to the internet that we can log in through a device and see. Obviously, cameras are a big deal in law enforcement. I've spent the last 2.5, 3 years of my life almost talking exclusively about body cameras to different agencies, assuring them, of their data protection as they use the cloud and store literally petabytes of content in the cloud. So the overall mission for law enforcement is to protect lives and obviously now protect the truth. And this applies not only for private citizens but for themselves, right? Reality is, you go walk down the street and what do you see? Like an officer-involved shooting, something happening. Typically, there's 20 people with their phones out recording the incident, right? And so we think about some of these devices that they're wearing and data that they're capturing. It's really important that we're able to derive intelligence from that. We don't want a 10-second clip of something happening where we're seeing use of force And yeah, that's from somebody's cell phone. We want to see the start to finish of the event, right? So it's all about protecting lives for them and protecting the truth. And so we've got all these things that have happened, and as I mentioned, we've got technologies that they're investing in, the gunshot detections, the cameras, drones, those types of things. Now, here's the challenge with this, is that each one of these systems is completely siloed, right? Where we've got data that's streaming into one database and is accessed through one app for each one of these systems, right? It's very difficult to now bring unstructured data and relate it together. And I'll go into that scenario that I talked about before where we've got ShotSpotter set up and we're able to identify where a gunshot goes off, but there's a whole wealth of other information that could be potentially pulling from IoT connected devices in that same location. Right? Wouldn't it be great to be able to visualize that in a single map view or a single source that we could relate all of the information together and use it in real time, and then also use it after the fact. We're getting a lot of gunshots in this location at this time of day when the weather is like this, right? We can start to apply some predictive scenarios to that to say, okay, let's go in and figure out when this is likely to occur, and we can deploy more officers in that location. And this is what really all about that data analysis is. So we've got disparate vertical systems, security and compliance challenges with that rapid evolution. I talked about the Ring doorbell that I installed. So I was looking at them, I think, a month and a half prior at Costco, and then I pulled it up online, and they had a new one out already. And it's changing so quickly that how do we get in front of it from a technology standpoint? So there are ways, and we're going to talk about some of that today. But basically, and it all starts and ends with cloud, right? It begins and ends with cloud. But storage and compute requirements. So these things, we talk about some of this advanced processing. Camera devices. We've got 2,000 cameras, in Miami, in Miami-Dade. And those all flow into our real-time crime center, right? So how do we employ a staff that can watch all 2,000 cameras at one time? We can't, right? But what we can do now is we can leverage some of the compute capabilities and the artificial intelligence capabilities that can help us derive intelligence from that data without having to have a human there to look at it. And I'm talking about scenarios like someone's left a bag on a street corner that might have a bomb in it, right? Or we have a group of people running in one direction and one guy or one person running in the other direction, right? If we can throw a flag up when that event occurs, that's extremely important, right? And then we can notify officers proactively. So that hot path data that I'm talking about, right, that's streaming into the cloud, that gives us access to hyperscale compute, that gives us access to artificial intelligence, that's where that all comes together, right? And then that's the analysis challenge, right? Is how do we get these tools in place locally that can analyze that data and do it in a way that is quick and efficient and doesn't require a human to go in and actually identify, oh look, a gun has been drawn. We have technology that we've built at Microsoft right now that law enforcement agencies are using, that when somebody draws a weapon on camera, we can identify the objects. Those objects can then be flagged and then notify police. So this is important stuff that we're doing. When you think about the ability to scale effort, right? So going back to that one of those first slides that I showed where how do we put more officers on the ground to respond to these things? Wouldn't it be great if at a gas station somebody draws a weapon, we can just notify officers that that's occurred and they can be dispatched to that location without any human intervention, right? That's what we're talking about with this technology. So it really has a lot of, I think a lot of breadth in terms of the capabilities and where we're moving. All right, so this is really what we're doing in Azure. And I'm going to hand off to Brandon here in just a second, and he's going to explore some of these scenarios. But basically, we've got several different layers that are part of our cloud offering that allow us to do all of these things, that allow us to bring together those siloed data streams, to build them into a single platform, to go through and actually recognize the unstructured data patterns and relate them together, right? To bring that LPR data, the video data, the ShotSpotter data, all together, body-worn cameras, whatever that is, right? And then analyze it. And we do that through something called the Azure IoT Suite and the IoT Hub. And so we built a demo for you today that talks about that. And just to explore this scenario a little bit, I don't want to steal your thunder.
No, steal away.
All right, so one of the partners that we work with, so we're partnered with most of the body-worn camera providers out there, with the exception of a couple, and they've taken their solution and deployed it in our cloud, and of course the data that's being captured through all of these devices, the officers on shift is turning their camera on and off all day. They go back to the station and they dock that camera and all the data is uploaded to the cloud where it's managed by an evidence management platform, right? And that's really where all of these fancy artificial intelligence things start to happen, right? Where we can go through and automatically tag things that happen over the course of that officer's shift. We can redact content, so in the case where there's a FOIA or public records request, we can automatically blur faces in that content, things like that. So that's really where it all happens. And the demo that we've built is these body-worn camera manufacturers have a real challenge with training their officers when they get into a really stressful situation to turn that camera on and start the recording, right? Because these cameras can't be running all the time. They would just capture too much data. I'll give you the stats. So it's every officer for a 12-hour shift captures anywhere between, I think, about 4 and 8 gigabytes of data per day. And that's turning the camera on and off when they need to, right? So we can imagine how much data there would be if they didn't. So training is a big part of this. The other part of this is, how do I identify when an officer is in trouble, right? So when an officer that's out there on patrol pulls his weapon or draws his weapon, how can we send that information back to a real-time crime center or a local police department to say, Jeff has drawn his weapon and needs some assistance? Or better yet, how do we connect to that officer's body-worn camera and the dispatch center can see the video in real time of what that officer is seeing after they've drawn their weapon, right? So we can provide real-time intelligence back to other officers that are responding on scene. So with that, I'm going to hand off to Brandon now, who's going to walk through the demo. And yeah.
Perfect. Thank you, Jeff. Yeah, so a lot of what Jeff just described is things that we're actively working on with some of the partners. Some of this stuff that I'm going to show you, we're working on. It's actually not live today, but there's talks. Because if you think about law enforcement and how officers operate, they're in the field, right? And how they're tethered, depending on if they're in a city or in a rural environment, they may or may not have 3G or 4G. So in some circumstances, this may work or may not work. And how do they relay those IoT messages back to IT Hub or Azure? So in some of these circumstances, we're looking at edge devices. So we still want to capture that data. It's on an edge device. It's computed in real time, but we may not be able to go right back to Azure until we get to a point that we have broadband or some way to be connected. So basically, when we went to our partners and we began these discussions, we wanted to kind of illustrate how easy it was and how simple it was to build a demo. Build something in Azure using the components for IoT, stream analytics, and some of the cool things I'm about to show you. So in the diagram that you see, I always like to start with this. Potentially, this is basically what's running in Azure. So if you look at the actual officer and the police vehicle, because the police vehicle itself, a lot of our partners, especially our in-car providers, who have the LPR system, some of them actually have cameras in the car, up to 4 cameras. A lot of those vendors are also in the body-worn camera market. So they're capturing tons and tons of metadata, long and lat, their vehicle diagnostics. In some circumstances, we've actually been told that fleet management, so basically the body-worn camera and some of these partners are actually getting to fleet management because they tap into the in-car systems and they know more about the car than the actual mechanics who work on the car. So we have all this data that we can provide to law enforcement, and it's how are we doing it, how are we crunching it, and it gets into kind of what Jeff was talking about, hot path and cold path. So in the illustration I'm going to show you, I'm actually going to have a couple events coming from a police vehicle, simulated of course, a couple events from an officer, some stressful events from an officer also. This demo is built all basically using IoT Hub, but it's over HTTP protocol. So obviously if you're using an IoT device or a field gateway device, the protocol is different. We're not going to get too deep into the technical nature of it. Those messages are basically sent through the IoT SDK through .NET. IoT Hub will actually relay those to Stream Analytics, and that actually gets sent to the cold path. The cold path that I'm showing here, I actually have Stream Analytics going to 2 different databases, more or less just showing you the flexibility of Stream Analytics, where it can receive one input message and actually cut off into multiple output streams.
Can you guys read that? Okay, it's a little fuzzy, right?
Oh,
Yeah, there you go.
Is that
There you go.
better? Perfect. Okay.
So yeah, cold path on this side, right?
Yep, cold path is the blue. And then basically the hot path is real-time data. So we actually built a demo where it's using SignalR. We send a message to IoT Hub. IoT Hub actually relays it back to the map itself. The map itself is really just an IoT device. So I turned the map into an IoT device that accepts messages from IoT Hub asynchronously, and that actually uses SignalR to pump it back down to the client side. And really just to showcase the real-time situational dashboard. This entire demo that I'm going to show you, we actually have time. I'm actually going to go through and show you how simple it is to build it in Azure. So we're actually going to go through step by step and build all the components out. I'm going to walk you through it, and then we'll show you working. So, any questions so far? No? Perfect. Okay.
Should we ask you some questions? Make sure you're paying attention. So
No, everyone's paying attention. It's hard to see.
You mentioned there's 5 different devices. Do you include the speed, those speed devices about knowing the speed of the car?
So those are part of the vehicle diagnostics.
No, I mean like the 2 rubber strips they throw on the highway to be able to determine if people are speeding in that neighborhood. Not the speed of a police car, but the speed of people.
That's
a lot of metrics that
there are a lot of different types of connectors that we support. Like is it in the thousands? It's in the neighborhood.
Well, no,
of
yeah.
thousands,
So
right?
I mean, it's a case-by-case scenario. But yeah, there's a lot of different connectors. So even if your device is not internet capable, we offer a field gateway. So we can have discussions if you're in that business. We can talk about how we enable you. So, okay. So I'm actually going to show you the demo first, and then we're actually going to walk through and build it. So I'm going to go over to basically the landing page, and if you guys, some of you guys have laptops out, so if you guys want to be a part of this, you can, actually. Please don't click on too much stuff, because you'll mess up the demo. So basically what I'm showing you here is the IoT devices. So if I actually go to devices, I actually built a simple UI. It has example code around it. It communicates to the SDK. With a simple click of a button, you can actually add IoT devices, provision devices, and you can deactivate, activate, and remove them through IoT Hub. The map device here, like I said, you actually create a map device the same way. You can remove, deactivate, and activate a device, and actually communicates with Azure IoT Hub, and activates and deactivates the device. And we'll go through this once I rebuild this entire demo. Oops. And they said get on the demo Wi-Fi because it's better. There we go.
There it goes.
All right, let's go back. So I have 6 officers. Each officer with this demo, actually every 2 seconds, is getting a random longitude and latitude within a bounding box. So there's a bounding box from lat and long around the city of Charlotte. So city of Charlotte's about to get very dangerous very quickly. So you have an officer here, and right here is 2 buttons. One is basically going to simulate an officer draws his weapon. Like Jeff said, a lot of our partners are working with 2 of them in particular have holsters that when you draw a weapon, it automatically turns the body-worn camera on. Our vision, and the vision that we're working with most of our partners is let's take it one step further. Let's turn on the body-worn camera, but let's send an IoT message to IoT Hub and relay that back to a real-time situational dashboard so the officer doesn't have to respond through a radio. They can just somebody can be called in for help or whatever else automatically.
And so this partner in particular, actually there's a couple of them now that have developed smart holsters that identify when the weapon has been drawn, and it activates the camera, right? So I talked about that training gap. So the weapon is drawn, camera activates, pings back to local real-time crime center, which is what this simulates. So what Brandon has built is, as he turns these IoT devices on, we imagine that this is actually hooked up to that smart holster or to the officer's light bar in the vehicle, getting those vehicle diagnostics, or to the trunk, which is another system he's connected in this case. So.
Yep, thank you, Jeff. So on a separate tab here, because in real time, so if you guys wanted to pull up IoT Officer X1 at azurewebsites.net and go to Maps, you would actually see these popping on because it uses SignalR. So if I go over here to, say, Officer Loving, and I activate a weapon, it sends an IoT message to IoT Hub. You can see that this event actually raised the heart rate. So one thing we're talking to officers and law enforcement about is wearable devices. So what if an officer is on a foot chase and his heart rate gets elevated? How powerful would that be to let someone know that the officer's heart rate is? Maybe he's drew a weapon or he's in a situation where he can't radio and his vitals are going off the charts. So that's important data that we want to capture and then react to. So if I go over to the map, and of course it didn't actually load. unless somebody unchecked it. It's a problem about demoing live. There we go. Immediately you can see the actual weapon was holstered. I have a little heart flag here. You can say he is located.
I think the internet connection is just
There we go.
crummy. There you go.
If I come over and basically activate a light bar, a body-worn camera. And if we think about what's actually happening here, back at the diagram, an IoT message is being sent to IoT Hub. IoT Hub is relaying it back to the device. It's being plotted back on the map, right? There we go. What else I built into the demo to kind of showcase and illustrate this is more or less an auto mode. So how do we populate this data in real time? So every 2 seconds, a random event is actually occurring. You can start seeing events come and go in real time, all through IoT Hub and Stream Analytics.
You show the video too?
Yeah.
Yeah, so we talked about, I mean, first of all, think about the information that we're capturing and being able to relay back to someone else that can then share that. It's pretty powerful here. And we talked about that scenario where we can now pull live feeds off these cameras. These camera systems are getting really, really advanced where we've got biometrics built into them, accelerometers, but also are connected to things like the officer's cell phone. Or one of our vendors, you can get within 250 feet of the car, it will stream back to the car. So we have a real opportunity here, I think, to be able to get, first of all, information in real time about what's happening to these police officers on patrol, but then also the data that they're capturing through these devices. So this is a really interesting application of IoT technologies. And even though it looks simulated, these are capable. This is using the IoT Hub in Azure, and all we have is just basically some buttons in lieu of an actual button that's connected to a weapon or a holster, right? So there's the scenario is it really applies here.
Yeah, most of the body-worn camera vendors, I mean, most all of them, they're all Wi-Fi enabled anyways. So holsters are triggered through a Bluetooth connection, and then through Wi-Fi as long as we have a good enough broadband. So we're looking at not public sector, but law enforcement has its own what's called FirstNet or Band 14. We're still a little ways out, but essentially it would be a private band similar to 4G or 3G dedicated to law enforcement or first responders. And it is actually powerful enough to do live streaming and some of these capabilities. So I just clicked on an example here. We have a video of, I forget what it is, it's Border Patrol example that we have. So let's actually just dive into the components and build this out from scratch here, just to show you how.
I showed this to the mayor of Charlotte, by the way, and she freaked out. She really thought some of it was happening. So it's pretty effective, especially when we get into the analysis side too. She's like, is that really happening in our city right now? This was right around that time that I don't know if you remember, they had that issue it was a big police trust issue a few months ago with someone getting shot. Mind you, what city isn't having that, I guess, right now? But
is that better for everybody?
I don't know. It's yeah, that's better, Brandon.
Is that better? Okay.
Yeah, one more time. There you go.
This would be challenging. Okay.
I can see it fine.
Really big for me.
You guys back there.
All right, so I'll just show you how this built out. So the demo you just saw is actually running in Azure right now. Some of these components, less than 90 days, will actually be available in Azure Government. I think Tom Keene had an announcement this morning in his keynote regarding IoT Hub. So what you're seeing today is actually Azure Commercial, but these components will be available, I'm told, in 90 days in Azure Government. So basically, you saw the hot path goes to actually DocumentDB NoSQL database. I have an IoT Hub instance running. App Insights was provisioned essentially because I provisioned a web app. So basically the website is a app services web app. I have Stream Analytics, which is basically used to pluck messages live out of IoT Hub. There's another way to do it without using Stream Analytics, but requires actual custom coding. And that's basically it. And the service plan is basically to run my app services. So we're going to quickly recreate this. So create a brand new resource group or a logical container for the resources that I'm about to create. I'm going to call IoT X3. And sure, we'll live in South Central US. How many people have an Azure subscription today? A few? Okay.
How many developers in the room?
Few? Okay. That's good. How many people have actually played with IoT in Azure today so far? Okay. Do you guys Raspberry Pi or just playing with IoT Hub or actually connected devices? Excuse me?
Arduino.
Oh, okay.
Yeah.
Got it. So I'm going to quickly go ahead and provision all of the actual resources that I need. So document DB.
Following up on that question, would you say the best way to get involved and start understanding it is to start with Azure or to start with something like Arduino or Raspberry Pi?
So two different things, right? So you have the device. So there's learning curve of the device.
Right.
Then you have the SDKs in Azure. So I would say the device is probably a larger learning curve than adopting, say, Azure or the actual SDKs. That's actually pretty straightforward. So how I learned and how most people learn from is really just going out and buying a device, similar to Raspberry Pi, and hook it up to Azure IoT Hub and start to look how security, because security is really the large question when we talk about IoT. There's multiple layers that you have to protect, so you have to actually have the device. Now that's actually, in our circumstances, pretty easy because it's on an officer. Now, an officer may leave it on his car seat, window down, but there's those things. You need to protect the device. You need to protect the endpoints, and then the data once it resides, and then basically the UI layer of when you're presenting that data. So there's, and we actually have lengthy documents around the security of IoT that you guys can go through. We have a whole bunch of documents that will help you go through and set it up. We think about IoT in a very security-centric way, so it's near and dear to our heart. So,
YouTube is your friend, by the way, when it comes to these types of things.
So we'll create docdb3, and click create. We'll create a web app once this goes through here.
You guys been seeing a lot of demos today? Is it better than slides, right? Yeah.
I have naming conventions I'm trying to follow. We don't need app insights.
So what's the web app doing in this case?
Oh, well, I guess so the web app is basically the website. So part of app services, you can deploy Java apps, .NET apps. It's basically our PaaS services for hosting IaaS in the cloud. Stream Analytics is plucking messages live out of the IoT stream and writing them to DocumentDB in JSON format.
You see how smoothly this is going for Brandon. This is, in fact, this easy.
We'll get to the good stuff. I guess I could have had the shell built out for you guys. So the last thing we'll create is the actual IoT Hub itself. I mean, if you had to take a step back and think about it, if we didn't have Azure, we didn't have the cloud, and we didn't have the platform for you guys to leverage. Think about the amount of work you would have to do and the amount of programming you would have to do to put together even a demo that I'm about to show you. So, I mean, it could take, develop, 10 people a year to develop basically what I'm going to show you. So just at least the orchestration aspect of it. So when you look at Azure and look at the building blocks, the components that you can leverage, and you're actually going through the re-architecture or redesign of a system, think outside the box of IaaS. Think about all the services that we offer and how they attribute to each other, and try to use them to build a great solution. So X3, we'll keep it fairly small, S1. Okay, so I should have basically all the services that I need. We'll create it if I go back to the resource group here. X3. We'll actually start configuring these resources now. So I have a DocumentDB, I have an IoT Hub, I have a web app, and then I have a Stream Analytics service. So I'll go to DocumentDB real quick. I need to create my collection. So a place to put this information. So I'll go ahead and do IoT collection. We don't need it very large because we'll get rid of it, and we'll actually call this IoT messages. This will all make sense in a second. So the actual demo that I showed you, nothing communicates with DocumentDB. The only communication, there's no state. The only communication back and forth in that demo is IoT Hub. There's no state, there's no connectors, no data layer for the document, no SQL. So all the building blocks here, I'll show you how easy it is to connect IoT Hub to Stream Analytics to DocumentDB. And then after that, we'll actually show you a Power BI connector to DocumentDB and how you actually visualize all this data afterwards and how simple it is. Okay, I have my collection created. I'm going to quickly go back and we'll go to Stream Analytics. So when you look at Stream Analytics, you have inputs, query, and outputs. So the input is how I want to get my data. It's basically going to be from IoT Hub. So I go to inputs. I'll actually name this IoT in because I'm creative. It's a data stream, and it's coming from IoT Hub. Automatically, it will actually pull in the IoT Hub from this current subscription, fill out all the information for you. You can obviously override this. So go ahead and create. It makes a connection from Stream Analytics to IoT, takes care of security for you. We'll close this. And I'm not ready for query yet. We'll go to outputs. So basically, once I accept the message from IoT Hub, where are we going to stick it? We want to stick it to DocumentDB. So we'll actually call it out.docdb. We're going to go to, here's all the output. So SQL, blob storage, table storage, service bus, data lake, Power BI, which would be a live feed. So we'll go down to DocumentDB. Again, pulls in the DocumentDB. We're going to connect to XB3, IoT messages, and we'll collect IoT collection. We did this was, I think it was IoT collection. Create. I need to verify my input though. Demo would have been bad. I actually connected to the wrong IoT Hub. Stuff would not have worked. We'll add a new input here and we'll connect to the right one. We want to use 3. There we go. Okay, so the messages that are actually being sent from IoT Hub is, I don't know if I can make this any bigger. There we go. So it's very simple. So every time a button is clicked, we have an identifying event. So it's a simple GUID that's being derived. We have a device ID and a unit ID. The device ID is really the device ID. Unit ID is the officer ID in this context. We have the time of the event. We have the event type, just simple text. Okay, it's a proof of concept. And then we have the longitude and latitude. So this is the actual JSON metadata that's sent to IoT Hub. It's then being sent to Stream Analytics. So basically what happens is when we create, I thought I did this. Let that finish here, 1 second. We need to create a query. So basically we have our inputs, the IoT input, and we have a DocumentDB output. So it's a SQL-like syntax. So we're selecting ID, device ID, unit ID, time, event, launch, lat. So similar to this format, okay? And we're basically into DocumentDB from IoT in. So the similar syntax will go right into SQL or other data stores. Perfect, okay. Then we need to start it. And that is basically it. So I have the solution running in Visual Studio here. I apologize, it's very small. The only cool part you really need to see to make this demo work is the actual IoT connection string here that I need to replace.
You zoom in.
Huh?
You just zoom in.
Yeah, I will. So I'm going to go to IoT Hubs, get a shared access policy. I'm going to do a big security no-no and give my demo the keys to the kingdom. Yeah. You can control and give tighter security. So your devices obviously wouldn't have access. They would only have, a very limited access policy. So all I'm doing here, I don't even know if I'm not going to zoom in. So all I'm doing here is basically putting that connection string into an app settings. I know it's very hard to see. I'm going to right-click on the actual solution inside of Visual Studio. I'm going to do a publish, which basically will make a connection to Azure because my credentials are already in there. Basically, I'm publishing to the actual web app for the demo. Going to publish to IoT Officer X3, click OK, and then publish. Basically, it's just going to compile the code and then release it to the web app. It actually failed. Uh-oh. 1 second. I was publishing to an old web app instance. So it's building right now. It's going to publish. It's going to open up a new browser to the actual demo, and then we'll test it out. One thing I wanted to show everyone is I actually built a dashboard with all the components. So obviously Azure, we're collecting a ton of telemetry with most of our services. So you can build rich dashboards. A lot of the telemetry that was captured is actually stored in blob storage. You could hook it up to log analytics and do other great things with it. But if I go back here, you can see I actually have number of messages have been sent. This is a different demo. Number of devices. You have graphs for the web app. We have DocumentDB stuff that's hidden over here and some stream analytics stuff. I didn't have App Insights wired up, but you could also add those in there. So here's the brand new demo that we built. There is no actual devices over here. So if I go over to devices, we can click Create on the map. This is using the actual IoT SDK. We'll activate that device. We'll say we'll create 6 devices. Click Add. It will go through and provision 5 devices. That's a bug. We'll activate each of the devices. We'll come over to the IoT demo. We'll actually see those 5 devices now show up with random long and lat. And if we open the map here, doing it on time.
Good. Yep, you got 10 minutes.
We'll throw a couple events on. We'll see them show up. And what we'll do is we'll actually come over and we'll go back to DocumentDB and ensure they actually got passed through Stream Analytics and stored in DocumentDB. So we'll go through, just validate the messages were sent. The 3 messages, and here they are. So it's really that simple, that easy to connect those building blocks within Azure to make a solution through IoT Hub, or through IoT. So it's the disconnected aspect of it when you play with a Raspberry Pi. That's really the difficult part of it. But once you're able to make that device connected either through one of our IoT field gateways to Azure, the rest is actually fairly simple. And then I'm actually going to hand it back over to Jeff. Within this demo, we actually have, let me go over to a different screen here.
How many folks have played with Power BI? How many people love it? All those that have played with it, right?
We're a big fan in the back.
Let this be a message to you. Anybody that's played with Power BI loves it.
Yeah.
Well,
so right here is Power BI. This is actually Power BI embedded. So I'm sure everyone has heard of Power BI. You can actually embed Power BI inside of reporting services reports now. You can embed it inside of web apps, websites, and do a lot of cool things. This is basically just to see a Power BI report that was built to connect to that DocumentDB NoSQL database. And then we did a little bit of manipulation inside of Power BI to build this very simple Power BI report that you could basically say, Officer 4, what events was he targeted to? So the important part is now we have all this data that we want to capture. What do we want to do with it? How do we want to learn from it? How can we do better, smarter policing with this data? Like Jeff said, this data today is siloed. So our goal and initiative is to put it into an Azure data lake or unstructured data store where we can actually aggregate and do a lot of deep learning and AI type stuff on it. So I'll actually hand it over to Jeff here. Push 5.
All right, thanks. I'm trying to find the new Gartner Magic Quadrant that, how many people here use Tableau? Sort of, yeah.
You're
okay.
allowed.
Yeah, you're allowed. So Power BI and Tableau recently, Microsoft and Tableau, I should say, are really the thought leaders right now in the BI space. And we know this can change, but this is something that we've worked really hard on. What's really interesting is that I used to actually be a SQL database platform architect that worked for Microsoft, selling SQL Server. And my wife actually works for Tableau. So you know, she used to come into my office when I was doing presentations, and she'd be like, "So you're going with the pie chart again, huh?" And I'm like, "Get out of my office." So you know, Power BI has come a long way the last couple of years. We now have a desktop client instead of actually having to use Excel for this. So I believe this is actually a free download. You can go ahead and go out there and download it and play around with all of your data. It works with Excel-based data. It works with DocumentDB that we're going to show you in just a second. You know, a lot of different data connectors. We can actually even randomly create data inside the tool and relate it, which is what I'm going to show you today.
I'll just show them all the data connectors.
Oh, okay.
It is a lengthy list. We should have you supported. So.
Yep. So I'm gonna zoom in on this just a little bit. So this is an example of that's not where I was on Zoom. This is an example of the type of report that we can generate. If I make this a little bigger, yeah. That out of this cool path data. So I talked about having that after the fact data that we can go in and analyze, right? And this is really what we're doing in this case. And it's hard to see, but you know, we obviously can get a sense of where these events are occurring on the map. So when the weapon's drawn, light bars are activated, that type of thing. Then perform analysis. We can also break it down by officer down here, right? And unfortunately, we're not getting the officer name out of the data feed, which is, I guess, the demo guy's fault. But we really want to make sure that's happening, right? We don't want to just look at Officer 1. We want to know that it was, in fact, Officer Jeff King that drew his weapon the most number of times, right? And we can do that pretty easily. And even though it's not coming out of the data feed, and let me just show you what that looks like. So if I go in here and we just take a look at the queries that are out there. So this is the data that's coming in off of Brandon's DocumentDB connection. It's just a JSON file basically that's giving us all of the lat longs and the officers that actually created the events and time of day, other information like that, right? Now the challenge is as we look at this data, and I don't know if you can see this. Let me just zoom in or try and zoom in here. So you can see officer ID at the top here, where we've got the officer, but we don't have the actual individual. So what I want to do is I need to create a table where I can relate the officer name back to the actual ID that's coming out of the JSON file. So to do that, it's pretty easy. We're in Power BI. I can go ahead and I can close this. And I can simply get data. And I've created a spreadsheet ahead of time, which I'll show you here. Whoops, I don't know what's going to launch. Hopefully not anything confidential. All right, there it is. So I've created this table ahead of time, and this is basically just giving us an officer ID and an officer name so that we can actually relate these two data points together. So we're going to create almost like a lookup table for those of you that do any kind of analytic BI, so a dimension table looking up a description. So what I can do is I can actually import this data into Power BI. So I'm going to say get data. We're going to pull in the Excel file. And I'm going to navigate down on my desktop. I've got demo. And we're going to click open. And it's going to import that data for us. Now I can actually define if we've got multiple sheets attached to this Excel file, we can tell it what sheet we want to bring in. I'm going to select this, and you see it's going to bring my data in. I don't know if it's actually making sense there, but you can now see on sheet 1 where I've got officer ID, officer name. So I'm going to go ahead and I'm going to load that into my data. So it's connecting to the model, it's loading our data. So one of the things that Power BI does is it allows us to bring in data from multiple sources, relate it together, actually apply changes to that data. So think of the standard and integration services, some of the old ETL capabilities that we used to manage through SSIS. we now have a lot of those capabilities actually built into a desktop tool that's free. Right? And then we can use Excel, we can use a lot of different data manipulation tools. So what we've done is we've basically imported this, and what I would consider this to be is a semantic layer, right? Where we've got data that's living inside of a database that is now synthesized in my memory on my machine, and we can start doing some things with it. So we've got, on the left-hand side, we see two tables, right? And this is the table view of that same data that I just imported. And if I just zoom in here, you can see, so Brandon's data from his JSON files are coming in on the left, and we've got all of those data points that we talked about that show up in his demo, longitude, latitude, ID, things like that. And then we've got this thing called Sheet 1 on the right-hand side. Now I want to rename this just to be consistent, right? So we'll just double-click, and you can see how easily this is. I don't have to run any complex SQL. So we can just say dim officer name. Now what do I want to do, right? I'm going to ask you guys, any guesses as to what I need to do here to relate these two together? Yes, so we have to join on the keys, right? So we have a one-to-many ratio here where we've got, a single ID and a single officer name. We need to pull that down and connect it to our officer ID over in the other table, and we can do that. All right, so I'm going to go ahead and connect those two things. Hopefully it works. Maybe I need to go the other way. And there it is. All right, so now I've got basically a connector, and it's sort of hard to see. I'm going to move the table over. You can see I've got a connector between my JSON file and my lookup table. So now if we go back over to our data, we can see in our field names here on the right-hand side that in addition to Brandon's data, I've got something called dim officer name that I can now expand. And I can bring into this visualization. So where we've got officer just numbers down here on the, whoops, whoa, super zoom. On the left-hand side, now I can actually bring in an officer ID. So I'm going to go ahead and I'm going to expand my visualizations tab. And I've got a group up at the top. I highly recommend going in and downloading. This is a really awesome tool. Very easy to use. There's a lot of online demos. The capabilities are all out there. Even just taking a couple of Excel spreadsheets, that you've been boring your boss with for years and turning them into like an amazing visualization, it's so easy using this tool.
No programming really at all. It's just drag and drop. And
so now I can see, so where you've got the 1s and the 2s and the 3s and 4, I can actually just take the officer name and I can add it to this group. And if we zoom now down on this, we can see we've got all of the officer names now populated in this table from our lookup. Right, and what's nice about this is I can go in, and I keep having to zoom in here, but I can take a look and say, okay, well, just show me the body-worn camera activations, right? So I can select this data bar, and now it, corresponds and relates all of these data fields together and gives me an accurate representation. Now, for some reason, we've got some anomaly that's showing up in Portland, which I'm not really sure why, but on the map. But let's zoom back in over here, and now we can see all of the body-worn camera activations throughout the city of Charlotte for that particular day that we're filtering on. And what's nice about this is, I can go ahead and actually just select this chart, and I can start changing it, right? I can go and say, I want to see this visualization instead, right? Or I can change it to my wife's favorite, the pie chart, right? So those are the types of things we can do with this tool very, very easily. Brandon's built a great demo that generates a lot of information, so I just wanted to show you what some of those capabilities were, since this was supposed to be more of a technical sort of how-to. The hope is that we inspire you to do great things with these tools, and that was really the purpose of the demo. Anything you want to add to that?
No, that's pretty much
okay.
it. So I think we have a minute left to spare. And then
well, we had a minute up to 60, so we still have you for like another 31 and a half minutes. I'm kidding. So I just want to run just through a couple of final slides, which I know are your favorite things, and we'll finish up and take questions. So we've shown you the how. Granted, pretty quick demo. The 15-minute crash course on IoT and Power BI. But really, as we move to the new world order of cloud, there's one thing I want to keep in mind, and I want you to keep in mind when you think about this. And this applies to all levels of what you do. I don't care if you're law enforcement, if you're anybody else. Everybody looks at cloud services, and all they see is storage and compute. Why should I go to Amazon, or why shouldn't I go Amazon? I'm going to go and pick the lowest price, basically, right? Cloud is a lot more than that. And it's a lot more than that, especially to law enforcement. And as I said before, it's all about the things that we're building. We're building a service-based architecture in Azure that our partners and customers can connect to. And what's different about that is that Microsoft used to go out and create software. Right? We would code all the software. We're still doing that. Some of the products like SQL Server, Windows, all those things will always exist, right? But what's changing now is that instead of, if somebody in the law enforcement community comes to us and says, okay, we want you to build, or we need something that does X, Y, Z. Microsoft doesn't go out and try and code that anymore. Now we have services in our cloud that do that. And I'll give you an example. So all of our body-worn camera providers, I keep going back to this because it's so ever-present in my world, but all of our body-worn camera providers have needs around how they manage that data, how they manage that video. But they all have proprietary systems. They all have proprietary evidence management platforms that are connected to those devices. Taser has evidence.com, VView has, I don't even know what their cloud instance is called.
VV Solutions.
Is it VV Solutions? And they've got something on-premise that's called VeriPatrol. So there's a lot of different software that they've developed. What we can do in the cloud is when there is need for a FOIA request, where there's, they need to redact content, instead of going out and partnering with someone else, which they can do still and have a couple of them, we now have services available in our cloud that they can they're REST API-based services that they can just hook into from their app. That means that the customer doesn't have to go out and buy a new product. They can just recode a small portion of their SaaS solution to connect to these REST API services, and the feature lights up in the cloud for them. Right? So these are services that everybody can use. It doesn't matter what flavor of software you have. You can just connect to it. And this is the beauty of it. And this is really where we're going with cloud. And so, when we talk about, protecting lives, obviously important. We're doing a lot of that with these sensor devices. But, we're also protecting the truth. And this is where all of these scenarios come in around body cameras, right? And I'm not going to go through each one of these. But I don't know if you guys remember the Boston bombing, when they caught those guys and how they caught them. The FBI did it through crowdsourced photos and crowdsourced video, right? And that's why surveillance video and private citizens sharing data with the law enforcement communities is so important. And we need to layer technologies on top of that have access to just massive amounts of AI, artificial intelligence, and the only place you're going to get that is in a cloud-based service like Azure, right? We have the capabilities, we have the engineers working on it. I meet with them all the time down in Redmond, in Washington State, where we go and we actually bring customers to them or bring these partners to say, how do we improve these services? And these guys go out and they build it. And then we see those capabilities surface through our platforms and out to our customers, and our customers love them, and it's really an exciting place to be. So I've got, you guys will have access to this deck. Some of the really cool things we're doing you can actually see if you go to this website. Remember I talked about object detection, where we can, if somebody in a video draws a weapon, we can detect that weapon and flag it. You can actually go in and you can use these services. There's some demos out there. You can put a picture in, a URL to a JPEG or something, and it will actually go out and it'll give you an output that includes an object list, things like that. We're doing a lot in the court system right now around speech detection. So where we need to use like a police interview room recording type scenario, we need to extract all of the spoken content into a text file that gets sent to a public defender. We can do that. We can identify speakers. We can identify the faces. So facial detection, facial recognition, also emotion. So if somebody's smiling, somebody's unhappy. All of these things are part of our cognitive services platform and are really, really exciting ways to engage and leverage the cloud for our partners and for you guys. I'm going to give you, I've got one thing left to show you, and it's a video. And the video is the New York Police Department and how they're leveraging IoT and cognitive services together to make Lower Manhattan and the United States a safer place. It's about 3 minutes, I think.
But what if the cameras could all be watched in real time at a central location? Amazingly, today there is only one city where this is known to be possible: New York.
2 Crips were shot.
When it comes to technology, Police Commissioner Ray Kelly is a true believer and an early adopter.
We're big fans of cameras here. It's been a tremendous force multiplier, if you will, for law enforcement.
The city's ambitious effort to connect and monitor thousands of surveillance cameras has never been tried before. The result is called the Domain Awareness System.
This is the state of the art. It is the most sophisticated camera system that you'll see across the world.
Domain awareness takes in a steady stream of data from license plate readers, environmental sensors, and 4,000 closed-circuit cameras, the vast majority privately owned. The city designed the system after carefully studying the extensive CCTV network in London and trying to improve on it.
The reason that this is state-of-the-art is because this shows officers in real time what's happening, rather than being useful mainly for post-incident investigations, as is the system in London.
911, where's your emergency?
The system is integrated with 911 calls, so possible terrorist activity is flagged, and detailed information about the address is displayed, as well as the location of nearby cameras, which can be called up live or rewound as far back as 30 days. It reads license plates in every lane of every bridge and tunnel coming into Lower Manhattan and compares them to terror watch lists. It is also programmed to automatically spot suspicious behavior, like unattended bags sitting on a sidewalk. And it can search through huge amounts of video data to find specific shapes, movements, or colors. Watch what happens when you ask it to look for people wearing red near the New York Stock Exchange.
It's really a matter of 1 or 2 seconds. If these cameras weren't all on one system, what you'd have to do is you'd have to go to a pole, retrieve the video data, and then each camera would have to be looked at individually by a person to pull out the red shirt.
All right. So that's the end of our presentation. This is a URL where you can actually go and try out our cognitive services. Really interesting stuff. If you have questions, Brandon and I can answer them as well. If you get back to your office and want to go through a step-by-step demo, I'm sure Brandon would.
Sure. Yeah, reach out.
Oh, sorry. I think someone was taking a picture there, and did I ruin your picture? Did you get it?
No.
Yeah, I can. Any questions?
Has anybody played with cognitive services yet? REST APIs? No? Heck, yep. He's waving his hand again. He leaves now.
Do you have any implementation with satellite?
Not yet.
No.
Nope.
Go ahead.
Yeah.
Yeah, they're in GOV Incorporated. I'm a Microsoft partner, and I'm working for the district government
Okay.
and the U.S. federal government. I want to inquire about the release of the possible alpha version and the subsequently the beta version of the software.
Alpha version of IoT?
Yeah.
Okay. Yeah, if you want to, do you have a card that you can drop off?
Sure.
Are you guys already operating in Azure government? You have a subscription? Okay, you're a
Okay.
managed partner. Okay, yeah, just drop off your card.
Yep.
And then I can relay that to you. So.
All right. Any other questions? Was this interesting or yeah? Okay. Oh, go ahead.
So I got a question. I work as a contractor for the federal government, and one of the challenges that we have is bringing things like this to market is that frequently you don't have, well, vendors don't have, from what I can see, a soup to nuts, fed wrapped, ready to go solution. You know what I mean?
Yeah.
So
Sure.
these are all great technologies, but like when you try to get them approved within the federal government sphere, when you try to go through all that red tape,
Yep.
get things added onto the hardware compatibility, onto the software compatibility, so all that enterprise repository, all that stuff. That's the challenge. So I'm just, this is more of a comment than I guess than a question, is that we need you guys to, like that last video you just showed, how that was done for New York, and I guess it's kind of a customized system or whatever.
Sure.
And I guess you guys had some input into that. At some point, that has to become kind of a cookie cutter solution that, granted, can be optimized and tweaked for individual requirements, but that's kind of like ready to go. You know what I mean? And approved in the federal government space. Like
Yeah, and we're
I work at FPS, Federal Protective Services. They're responsible. We
Yeah, and I mean, the key differentiator between government cloud and what we're doing in our commercial space is our regulatory compliance alignments, right? And anything IoT Hub isn't out in Azure Government yet, which is why we're getting questions about, you know, alpha and when is it going to be released. It will get there. We're just not there yet. And you know, and it's one of those things where the services will eventually be in Azure Gov and they'll be FedRAMP certified, right? You know, I don't know. I don't have the roadmap. Do we know what the roadmap is on IoT Hub?
Yeah,
It's
90 days.
90 days. So it'll be there in 90 days, FedRAMPed, hopefully. So, you know, we're getting there slowly. We're just not, the whole soup to nuts implementation, you know, this stuff is so brand new for everybody in commercial sector as well, right? So it's one of those things where we've got the technology, we're proving it out, we're working with different agencies to do that. You know, we're building the stuff and we're building as fast as we can. And in government, it's even, as you know, more slow because we have to go through every single check and balance that, you know, is required of us to deploy a cloud and making sure it's compliant in all of those areas.
So one thing we're actually doing to help our ISV is we came out with a program called Azure Blueprint. Basically, all the work that we do making our compliance, so we're giving the platform that we're basically saying is FedRAMP 4 or DoD Level 4. But like what you're saying, the partners, their solutions also have to be compliant. So they have to go through the same process. But what we're doing is we're basically saying, well, here's the documentation for you to start. And then all you have to do is your application layer, FedRAMP. So your platform is, you know, guaranteed to be FedRAMP. And we're actually working with ISV. So it's the Blueprint program. So if you go out here, you can learn more about it. But it will help you basically get 50% there, and then the ISV only has to worry about the components that they're building the rest of the way. So,
yep. Any final questions?
I'm more interested in IoT than the actual use case right now. It's a great use case. I'm very impressed by your presentation. What other, besides this security use case for IoT, are there any other big use cases that you guys have been seeing on the horizon or that have been revealing themselves? I've heard elevators, I've heard
cars, elevators.
I mean, think about like traffic management. I mean, there's all, like from a city perspective, there's about 1 million. I mean, healthcare. I mean, there's so many different sort of scenarios that, I mean, think about any kind of connected device, right? Like, so healthcare, I mean, imagine having connected biometrics devices that, you know, could help scale the efforts of a healthcare worker, you know, that kind of, or a doctor, you know, that you know, I mean, there's so many. When you just go out and, I mean, just in your mind, think about all of the different connected devices that are out there in the market. And I'll give you an example of one that I got in trouble for, because the last time I said this, so I like to, I live in Georgia, I'm from Atlanta, and we like barbecue, and so I have a couple of smokers. You know, and I said this in another presentation. I said that I like to smoke meat, and everybody thought I said weed.
Yeah.
But so there are, you know, temperature sensors that are out there now that I can go to the movies with my family and monitor the cooker temperature and control the cooker from the movies through my mobile device. I mean, the types of scenarios are endless, right? I was thinking about, I think I have like 10 or 11 IoT devices just in my house now. If you count all the cameras and the robot vacuum cleaners and the, you know, I mean, whatever else, right? I mean, I think that, you know, you get this technology in the right hands in terms of innovation, and sky's the limit. And we're seeing it in law enforcement, right? I mean, some of these things are incredible that they're coming out with. You know, we just showed a simple, basic scenario, but I mean, it's amazing. And it's keeping officers safer, it's keeping citizens safer, and it's scaling efforts, right? So remember that $4.6 trillion in savings? That's where we're coming at this. It's like, how do we save money in public sector? How do we save money in commercial sector? Know when our elevators are about to break, right? Things like that. Know when our fleet is breaking down, or the likelihood that a part's going to wear out. We can get in front of that. I mean, the cost savings are incredible. So, all right. Thanks for those of you that stayed.
Thank you, everyone.
Thanks, guys.